how many people know, but I think the first recognized female data scientist was Florence Nightingale. She was a nurse during the Crimean War, taking care of all the patients there. And she realized after doing a bunch of analysis that it was more patients were actually dying because of the hygiene factors in the clinics as opposed to the actually war wounded. And the kind of work that she did there and the analysis that she did has actually laid the foundation for some of the hygiene factors that are obviously very, very applicable for all of the hospitals even now. Another example, in the early 1900s, Sir Gilbert Wallace was the head of the meteorology department in India, and he did some fascinating research. He collected data from all the ships that the British were actually flying, sailing to all of their colonies, and he had a team of 150 scientists. And what he discovered was this fascinating correlation where if the weather, this was the difference in temperature between Darwin, Australia, and Tahiti, and he noticed that whenever the temperature in Darwin, Australia was greater than the one in Tahiti, those were the years the monsoons would be successful in India. And whenever it was reversed, the pattern was reversed, the monsoons would fail. And really what he actually did in the early 1900s was discovered El Nino, Southern Oscillation phenomena. Of course, it was rediscovered in 1960s again and was recognized as a climatic phenomena. So this data science and the field of analytics has been around for a while. But why is it becoming very popular and why is it being talked about right now? And it's all about these three key trends. Again, this has stopped working, but it's really three things which I believe are really fueling this thing. One happens to be this massive explosion of data that we're generating every day. With billions of interconnected devices, be it smartphones, IoTs, PCs, laptops, every interaction that we do, machine to machine to human interaction is getting digitized. And we have a vast amount of information that's being generated every second, and we also have now means to store them and analyze them. The second, of course, is cloud and the massive, near infinite compute and storage power, which allows us to actually now store the information as well as process it. And then the most importantly, these really advanced algorithms that are being developed now, machine learning, deep neural nets, deep learning, and so on, which effectively now, if you look at the confluence of these three, really powerful algorithms applied onto really massive data sets using the computing power of the cloud literally is transforming the cloud into this mass producing facility for intelligent applications. And that's really fueling this kind of digital revolution that we're kind of going through, all backed by AI and backed by the cloud. So at this point, it really doesn't matter which industry sector you are in. You could be in healthcare trying to provide better personalized care. You could be in government trying to provide better citizen services, or in education trying to provide more adaptive learning solutions, or in agriculture trying to provide precision digital farming and so on. Every sector is being kind of transformed because of AI and the cloud. So what I'm going to do over the next few, 10 minutes, is just share 2 or 3 examples of what we've been doing in Microsoft and how I've applied AI towards better inclusive growth and empowerment for everyone, and how we've actually made the power of AI reach the last mile. The first one I want to talk about is in the area of healthcare, where we've been working with, specifically on the field of eye care. And as most of you probably know out here, I mean, we have close to about 280 plus people who are visually impaired across the world, out of which 53 million happen to be in India. And among them, about 12 million who are blind. Now, it turns out about 70% of that visual impairment or blindness can actually be avoided if proper care was taken or if proper early detection was done. So what we've done, working with LVPI, and we've also built a worldwide consortium of data providers, and using that we built machine learning models addressing various different aspects of eye care, myopia for kids, LASIK surgery, glaucoma, cataract surgery, and so on. And effectively what we've, with those models, what we've been able to do is provide the capability of really very capable doctors who are available in the tier 1 cities, basically, right? And for example, in case of LVPI, which is based out of Hyderabad, where they have all of their trained doctors. Now that knowledge And those abilities are now available even in the primary centers in the case of telemedicine and things like that. The government of Telangana is actually using these ML models now as part of the National Health Mission program, which is the Rashtriya Bal Swasthya Karyakram, which is effectively for screening of all the kids. And they're using that to reduce the time between screening and care, because now you can take these machine learning models and actually put it right at the point where the screening happens, where you don't have trained doctors, but instead you have some kind of trained technicians. And effectively what you can do now is much more effective triage. So this is not about replacing doctors, this is about making the job of doctors even more easier and effectively reducing some of the noise in the system, and in some cases also allowing for second opinions. The next example I want to share, just to kind of change track completely, is in agriculture. Now, if you look at India, which is, of course, again, very agriculture dependent. About 60% of our population still depends on their livelihood on agriculture. But in India and places like India, we do have a big problem in agriculture where everything is climate dependent. And every time you have issues with rains and monsoons fail or weather patterns change, the crops fail, and as a result of it, of course, it affects affects the farmers. And as most of you know, basically farmer suicides happen to be a very, very big issue for India. So what we set out to do was to see if we can use AI to really help farmers improve their profitability and productivity. And one of the experiments we did was in the government of AP again, where in the last Kharif season, we looked at how we can reduce the variability of climate by providing the farmers very specific information on which day they should sow the seed so they could maximize yield. And it turns out that using those machine learning models, basically, we managed to actually increase the yield by close to 35% for the farmers. Everybody who followed the advice given to us, even though we delayed the sowing by close to 3.5 weeks, folks actually followed those and they got 35+% increase in yield. We're of course increasing that. What started off with just one particular use case, we're now looking at how we can affect farming across the entire life cycle of planning, sowing, growing, then of course harvesting and then selling. And using machine learning to really kind of address and provide digital precision insights to farmers. One of the experiments that we're doing right now is basically for cotton farming, where we are providing farmers very specific information on which pests we believe are going to be hitting the crop. And to kind of give you an example of basically how we take the power of machine learning and actually make it reach the last mile, here's an example of basically what every farmer actually hears.
नमस्कार, UPL आदर्श किसान सेंटरमध्ये आपले स्वागत आहे. आपल्या सोनोशी गावातील वातावरणाची सद्यस्थिती आणि पिकांची अवस्था लक्षात घेता या अवस्थेमध्ये आपल्या कपाशी पिकावर रसचुसक किड्यांचे प्रादुर्भाव होण्याची दाट शक्यता आहे. नियंत्रण करण्यासाठी UPLचे लान्सर गोट 500 ग्रॅम प्रति एकर सोबत फॉस्किल 400 ml प्रति एकर प्रमाणे फवारणी करा. अधिक माहितीसाठी UPLच्या टोल फ्री नंबर 1800.
Okay, I'll skip that. So effectively what this thing was, a specific recommendation. Now we, given Bombay, I actually chose Marathi because we also do this thing in Maharashtra. We of course give it in the local language of the farmer. And it's a fascinating stat. This was an experiment that we did with UPL. And if you notice, they actually are in the business of providing recommendations to the farmers. And they used to see about a 40% uptick in the recommendations that they were giving. Now that we brought machine learning in place to give very specific recommendation to the farmer for their tract of land, we saw close to an 85% acceptance of that particular recommendation, which of course goes a long way towards actually solving some of the problems for the farmers. Finally, I want to just give you an example of basically what we did in the space of education. Now again in India, we have the highest enrollments in the K-12 program across the world. Which could be a great asset for any country, but of course, in our case, basically, we also have a very sad stat, which is about 70% of the people in the public school system will not graduate out of the K-12 program. So, which is, of course, a bit of a shame. So the question was, again, can we actually bring machine learning to help address that issue? And what we did was, again, working with one of the governments out here, we have a machine learning model that can very accurately now predict which are the kids who are at a risk for dropping out of schools. And what are the reasons basically why they are dropping out. And that now gives governments really very specific insights in terms of where to focus on, which district, which mandal, which school, and address the specific insights for a particular student as to why they are dropping out, if they want to do counseling or any other programs and so on. Now, these are examples that I shared specifically on individual areas, basically on education, on agriculture, healthcare, just to kind of make a point that for a specific domain, it's very easy to kind of get the data, figure out what the problem statement is, and then address them. But as we were working through these things, what was really fascinating and interesting is when we started seeing correlations in seemingly disparate domains, and we brought the data together. So for example, when we actually started looking at the child screening program that was happening in the case of the Health Mission program, where they were screening all the kids for various different parameters, we noticed that in Telangana, for example, visual impairment was one of the I think the second largest disease, the issues health issues that we saw. And it turned out that early, or rather undetected visual impairment actually contributed to school dropouts down the road. So it's kind of an interesting thing, basically, that instead of actually trying to solve it later on, when we find out that the person is at risk for dropping out, you could actually have solved it basically by getting the early signals basically from the healthcare side. Another interesting one, actually, just to kind of show those correlations, we started talking to a tribal village in Telangana, and this is actually a fascinating story, basically. A large part of this tribe actually suffers from iron deficiency anemia. Now again, you can actually look at it as a medical issue, basically, and solve this thing by providing supplements and doing other things to solve the problem of anemia. But if you actually start thinking about how to really solve this problem, it turns out that you actually need to actually think of it more from a larger system point of view, where you have to look at agriculture and education at the same time. Because to really solve this problem in the long term, it turns out that basically what we need to do is look at the kind of crops and the kind of recommendations that you need to give to the farmers, so that you need to provide locally sustainable crops which are rich in iron, basically, for the folks in that land. And then the second thing that you need to do is also provide the appropriate changes in terms of education and so on, so that people actually adopt those new practices and so on and so forth. So it's the real magic actually in AI happens when you start looking at data across the board, not necessarily in one domain, but bring various different data sources all together and then start finding some very interesting and fascinating correlations. So at the end, I mean, from at least our experience over the last few years as we've been working and tackling various different problems, we really do believe that AI can bring in huge solutions for huge societal problems. Yes, AI can be disruptive, basically, but if we are, I think the key thing is for us to actually be responsible and use it responsibly, and also use it for the better empowerment for all the people, and also make sure that all the power of this technology has a way to reach the last mile. So finally, I'm just going to, I know I'm really out of time, but I'm just going to leave you with one last example, which really truly shows how basically AI can be inclusive. And this is a specific case on autism and what we've done in that particular space. Turns out that almost 1 in 68, or I think 1 in 70 is the stat, kids who are being born in UK and US nowadays are being diagnosed with autism disability to some extent. From, I think, the year 2000 to 2010, autism had, I think, detection was almost 100% increase basically in US for folks who had autism disability. So here's an example of how AI can actually help and is helping.
SwiftKey Symbols is a communication app for people who are non-verbal, and it supports them in expressing themselves.
Rowan, my youngest brother, has low-functioning autism. He finds it difficult to communicate and can get very upset if he can't make himself understood. I took what we used at home with some symbols that my mum would print out, laminate, cut out, stick Velcro on, put them into folders, and I just thought I could make that easier. If we did it on an app, though more fun for Rowan because he loves technology.
The underlying AI technology which SwiftKey Symbols uses is the same technology which powers the SwiftKey keyboard. We use AI technology to be able to learn from the user's behavior, to see what they like to use in terms of their own style of language, to predict what's going to come next.
It works by having a library of symbols that you can pick and choose to build your sentence, and each symbol has a word associated with it. And we use SwiftKey AI predictive technology to learn what you've used previously, sentences that you've previously built, and then we surface what word you might want next and what symbol you might want next to build your sentence.
I want juice, please, Kate.
Wow. We developed it alongside Riverside School, which is a school specialising in learning difficulties.
To be able to express what they want without prompting is a really big thing.
We have so many pupils who are non-verbal but still have so much to say.
I think AI can just make everything in life more efficient so you can enjoy life to the max.
There's no better feeling than to hear a child say something that they've wanted to say and the look on their face after they've been able to say it. You can't really beat that because that's them expressing themselves and that's really what you want from them.
It's joyous. I don't think I can think of a better word for it. It's complete joy and celebration.
All right. With that, I'm just going to end. Thank you.